Hi there everybody, this is the video for Friday, November the 13th for my intro calc students. We're just going to go through one more example of the quotient rule, and we're going to use this question. So the question is, and this is example 5 because we're just continuing from where we left off yesterday's lesson. The graph of the curve y equals x squared minus 2x all over x squared plus x plus 1 has a maximum and a minimum between x equals negative 2 and x equals positive 2. Find the x coordinates of these points. So I'll give you a second, maybe pause the video and copy the question down, and then we'll get started on it. Alright, hopefully everybody's got the question copied down. And let's start by, first of all, making a strategy. What are we going to do to solve this thing? Well, we know that this particular graph is going to be some sort of curve, right? And x squared divided by an x squared would in fact just be a constant. So it's sort of a constant, but this doesn't exactly go into that. I could long divide it and find the remainder, but that wouldn't really help me get a handle on what it looks like, other than it would just kind of have sort of like something close to a constant with some sort of bulge in it. I do know that if there's a remainder, that remainder would be over 1 over x squared, and I do know that 1 over x squared as a graph looks something like this. So it's one of these kind of curves like that. But at the same time, if it's, again, x squared canceling x squared, it's some sort of constant, which would look like this. So imagine these kind of two graphs kind of merging together to make one picture. Something else I could do to kind of think about what this graph does is I could look at its limit. I was doing this with the class today. Suppose I actually wanted the limit of this thing. So here, let's see. What if I wanted the limit as x approached infinity of x squared minus 2x all over x squared plus x plus 1? So if you remember when we did limits, what we're going to do is we're going to times by 1 over x squared and 1 over x squared on the numerator and denominator, which is going to give me the limit as x approaches infinity of 1 minus 2 over x, 1 plus 1 over x plus 1 over x squared. So then when I plug in my limit for that, sorry, I'm moving around too much. So when I plug in my limit for that, I get 1 minus 2 over infinity all over 1 plus 1 over infinity plus 1 over infinity squared, which of course is 1 minus 0 over 1 plus 0 plus 0. So as you can see, my limit's 1. So now I'm kind of getting a picture in my head. Again, it's sort of a 1 over x squared graph. It's sort of a constant graph. And as I head to infinity, I know that I'm approaching my limit of 1. So putting all that together, I kind of have a picture of this in my head. And just for fun, let's take a look at what it would look like in Desmos. Hang on, let me get the question back. There we go. Before I go over to Desmos. And as you can see in Desmos, it ends up looking, oh, let me get rid of those. It ends up looking like this red line here. Right? Again, it's kind of a curve like that, but this part kind of ended up dipping into the negatives for just a bit. And the question says that there's a maximum, there it is, and a minimum, there it is, between negative 2 and 2. My job is to find those two x coordinates. Now, what do I know about those x coordinates? Well, I know that those x coordinates represent the maximum and the minimum, so they represent the tangent points, and the tangent line would have a slope of 0. So what I need to do is find the slope of this curve and set it to 0. So that's what we're going to do. We're going to find the slope of this line and set it to 0. So the slope of that line is going to be, of course, y primed. So that's my job here. I'm going to take, let me just get that nice and set. I'm going to take the function y equals, okay, what's my original function again here? Hold on. X squared minus 2x all over x squared plus x plus 1. And I'm going to find the slope, which of course is y primed, the derivative, and set it equal to 0. So that's my goal. Now, to actually find the derivative of this, I'm going to have to use my quotient law. And my quotient law looks like this. Y primed is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So, in this case, my y here is basically f of x over g of x. So f of x is this numerator, g of x is that denominator. I think I'm ready to put in to the formula. So it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. This is a good place to kind of think about what it is that we're doing here. Well, we are going to have to solve for x. We're looking for the x coordinates when this y primed, when this slope is 0. So keep in mind there's no point in expanding this denominator. I don't usually expand denominators when I do derivatives anyway, but in this case there's especially no point in doing it because I'm going to end up with a 0 here. In fact, I could even put that in right now. 0 is equal to x squared plus x plus 1 times 2x minus 2 minus x squared minus 2x times 2x plus 1 all over that denominator. And now if I times both sides of the equation by the denominator, it cancels on this side, and 0 times anything is still 0. So there we go. Denominator is dealt with. I make a point of this because I always watch students who think, oh, I've got to simplify everything when they get to this step, and they waste a whole bunch of time squaring something like this ugly trinomial here when it's going to go away anyway in this problem. So it's not worth worrying about. I do, however, have to actually expand all of this. So first term times those two terms is 2x cubed minus 2x squared. Second term times these two terms is plus 2x squared minus 2x. 1 times those two things is plus 2x minus 2. Then I'm going to FOIL those two things and distribute a negative. I'll try to do that all at once. That's minus 2x cubed minus x squared plus 4x squared and plus 2x. All right, I see some nice cancels that can happen here. That cancels that. That cancels that. And that cancels that. Negative 1x squared plus 4x squared is 3x squared. And plus 2x and minus 2. All right, I get a trinomial. Can I factor that trinomial? Are there any numbers? Let's use decomposition. 3 times negative 2 is negative 6. Are there two numbers that multiply to make negative 6 that add to make 2? And the answer to that is no. So I'm actually going to break out my quadratic formula. Okay, so there's the quadratic formula. So x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And I pointed out to the class that good thing that 2 is negative, because remember, if you end up with a negative under this radical bracket, you can't square root a negative, so that means there are no x values. But I've seen the graph. I know for a fact there's x values. There is two places that have a max and a min where the slope must be 0. So I know that I'm getting solutions, and here they come. It's negative 2 plus or minus, and that'd be 4 plus 24, so that's square root of 28, divided by 6. I pointed out to the class that if this was the answer, if all it wanted was the exact x coordinates like this in the textbook, this probably wouldn't be the final answer. You can simplify this. You can factor off square root of 4 out of the square root of 28, so it's actually negative 2 plus or minus 2 root 7 over 6. Factor a 2 out of the numerator and the denominator, and you get negative 1 plus or minus the square root of 7 over 3. And that is the final answer. And just for fun, I wanted to compare this answer to what Desmos was giving me. So I ran this through my calculator and found that if this is positive root 7, I get x is 0.54, and I rounded it to 3 decimal places, 9. And if I plug in a minus root 7, I get negative 1.21, and when I round it, 5. And if remember those two numbers, if we go to Desmos, we get exactly those two numbers. There it is. Negative 1.215 is this x-intercept, and positive 0.549 is that one. And just to double check that we did our derivative right, you can, if you put it into function notation, ask the Desmos to actually find you a derivative, and there it is. And here is the actual equation that we got, and as you can see, green, blue, we got the exact same derivative that Desmos would have got. And one last thing, if we wanted to actually just double check to make sure that we did the tangents right, we can actually ask Desmos to draw the tangent lines, which is just enter it as a y equation. So y equals negative 1 plus the square root of 7, close brackets, that's not where I want to close brackets, close brackets, divide by 3, and there we go. So that is the x coordinate, and yeah, we get an x coordinate of, oh, sorry, what am I saying? Yeah, that's the x coordinate right there, and that's its height. So, right, that's the, let's call that A. There we go, let's call that A. And if we ask this to do g of A, it'll actually give us oh, sorry, not g of A, I want f of A. If I ask it to do f of A, it'll give me that as a point, and if I actually ask it for A comma f of A, it will give me, and there it is. There's that minimum point. Let me get this kind of out of the way, and that out of the way. Move. There. There's that minimum point, and I can find you the tangent at that point if I want to. I can find you the tangent by going y minus f of A equals my slope. Now remember, slope is actually g of x, so that would be g of A times, and there you could even just stop right there. You can see now that that's the tangent line. And if you want to, see if you can do that for yourself for the maximum, the same way that I just found the tangent line for the minimum. Cool. So that was today's lesson. After that, just had a few minutes to work.